finally, these are the solutions for the Unit 9 review. As far as the multiple choice goes, I have given you guys to some extent the solutions in your Canvas modules. There are a couple of quizzes where you can just check your answers. The problems aren't included, you just check. If you guys need any help with the multiple choice, I would advise you to just ask me during class, send me an email, or come and see me on a Friday. I will be going through the free response in this video, and for the multiple choice, I just want to talk about the cheese problem, and then other than that, everything else will be in the free response. So, the cheese problem is questions 17, 18, 19, 20. So this is a really good question for just your overall knowledge of experiments and how you would assign treatments. So question 1 wants to know, what are the experimental units? Remember, experimental units are the things that you assign to the treatment group. So we're going to assign batches of cheese to each treatment group. In fact, they say right here, we're going to assign 10 batches of cheese at each combo. Identify the factors and explanatory variables. So you can see my picture drawn out like I taught you guys to do it in your notes. So this factor is temperature, this factor is stirring rate. What is the response variable? We are looking at the yield. So they tell you right here that they think that a higher or lower yield depends on the temperature and stirring rate. And obviously, if you're producing cheese, you're probably trying to get the best yield that you can. And then lastly, how many experimental units are needed? So they're trying to trick you with this one because they tell you 10 batches will be processed at each combination of temperature and stirring rate. And if you're not really careful about what they're actually saying there, you will get number 20 wrong. So number 20 is 60. They're telling you you want to assign 10 batches to each treatment group. Well, you have 6 treatment groups. You have 50 degrees at a rate of 60, 50 degrees at a rate of 90, 50 degrees at a rate of 120. That's 30 batches right there, and then you do the same for 60 degrees, which is another 30 batches. So total of 60 batches of cheese is what you'll need as experimental units. Okay, moving into the free response. So you can see here, these are my solutions. I typed up my solutions. The amount of writing that you need to do for this particular set of free response problems is painful. And one thing that I did not do a good job of, well, I think I didn't do a good job of it, was telling you guys that you needed to do these problems on a separate sheet of paper. There is no way that some of these problems can be answered in the amount of space that I gave you. Like question 5, describe an appropriate method for assigning the subjects. There's no way any of you guys can describe that in this little space. So I can almost say for sure, if you wrote any of your responses on these papers, you didn't write enough. There is no way that I left you enough room to do these on this paper. So I have my answers on a separate sheet and I typed them out. If you haven't done this yet and you want to type out your answers, I am okay with that. You can email them to me or you can print them out yourself. But one thing is, you should really be trying these problems before you just go through my solutions. I've said this before and I'll say it again, that I left these units, these last 3 units, I intentionally left them for last because I knew for sure they would be on your exam. So it is extremely important that you guys are actually trying these problems rather than just watching me solve them and writing things down. So, what is the response variable in the study about tractors and plots of land and draft? The response variable is your amount of draft. your treatments are the new hitch and the standard hitch. Your experimental units are the 2 large plots of land. Was randomization used properly in this study? Yes. The 2 hitches were randomly assigned to the 2 plots. And you must say yes, and in the very least, the hitches were randomly assigned to the plots. They're trying to confuse you by telling you 25 measurements of draft were also recorded, but that is not the randomization they're referring to. The randomization they're referring to is random assignment. So it's not that we're randomly selecting the points at which we measure draft, it's random assignment. The thing that makes an experiment is random assignment. So you assigned your experimental treatments to your experimental units to your treatment groups. Given that we're trying to determine whether the new hitch reduces draft, was replication used in this study? No. No replication was used in this study. Remember, you want more than 1 person in your treatment groups. There was only 1 experimental unit in each treatment group. So the standard hitch was used on 1 plot of land, and the new hitch was used on 1 plot of land. In order to have replication, you need more than 1 plot of land per hitch. Why? Because land is a confounding variable in this experiment. So it tells you at the top that draft is affected by environmental conditions such as soil type, terrain, and moisture. So they're telling you in the prompt that the type of land is going to affect the amount of draft. And then the other part of the prompt just says 2 large two large plots of land were used in this study, and they're not giving us any indication that those plots of land are similar. So because there is no replication, we won't know if it was the hitch or the plot of land that caused the difference in the draft. So I have said each hitch was only used on 1 plot of land, so we won't know if a difference in draft was due to the hitch or the plot of land. It would have been better for me to explain, the prompt says that soil type, terrain, and moisture affect draft, and so we won't know if it was the type of terrain or if it was the new hitch. You do want to refer back to part E in your solution, though. The part of the reason why plot of land is a confounding variable is because you didn't include more than 1 plot of land. If you included a bunch of plots of land, it would minimize the effects of that confounding. Okay, 2. So part A, you have to have 2 things in your response. So 1, you have to say that the block is better and why. And then 2, you need to compare that to the completely randomized design and clearly state why a completely randomized design is not better than a block design. So for an E, you had to give the block and why, and you also had to state the problem with completely randomized. Either one, you would get a P. So you can see down here that my response is pretty long. So I'm going to let you pause the video and take what you need, but essentially we're going to block by the location of the well. I would imagine that the ones by the burned forest have more arsenic. Is that what they're looking for? Yes, they're looking for arsenic. So I would imagine that there might be more arsenic in the wells by the burned forest, and I think that's what I said. So because of that, that could be a confounding variable. So in order to minimize the effects of that confounding, we're going to split the wells up by location. And then notice here's what I need to get my E. A completely randomized design does not give us control of how many of each type of well will be assigned to the treatment groups. You could end up with 3 forest wells and 1 granite well in one group, and then the opposite in the other, and that could lead to confounding. So you want to block by location. Completely randomized design does not help you minimize the effects of confounding. So remember, you have to have both in order to get an E. Part B, many of you guys missed it because you didn't do what they told you, which was identify the wells by number that are in each block. So I have here, as stated, our blocks are the location of the wells. Block 1 is going to be the granite ledge, 1, 2, 3, 4. Block 2 is going to be the burned forest, 5, 6, 7, 8. C, in order to get an E, you had to have these things. You had to clearly state that you know that you are assigning treatments within each block. You would get a partial credit or an incorrect if you did not make this clear. That has to be there. You have to use a random process. You say repeat for the second block, and then you compare, combine, conclude. So notice here that I start my response with, within each block, I will randomly assign the filters using 2-hat method, and then I describe it. So I'll write the number of each well on identical slips of paper. In a second hat, I will put another 4 identical slips, 2 with new filter, and then the other 2 labeled with the old filter. Shake both hats to randomize, pull 1 slip out of each hat, and then explicitly state that the well from one hat will be assigned to the filter from the other. Repeat until all 4 wells have been assigned a filter. And then down here, I have repeat for the forest wells. And I should add in compare at the end, combine, conclude. So compare the results for the forest wells to each other, compare the results to the granite ledge wells to each other, combine, and make a conclusion. Okay, number 3. So the one thing that makes something an experiment as opposed to a study is random assignment. So part A, the study was an experiment because the treatments were randomly assigned by the researchers. 2, no, we did not compare our D-cycloserine group with the people that had to go to 8 sessions. We compared D-cycloserine to a placebo. So we cannot make the statement that it is as effective as 8 therapy sessions. So we can conclude that the D-cycloserine pill and the 2 therapy sessions show significantly more improvement than a placebo and 2 therapy sessions. However, there is no basis for comparison with another group of people with acrophobia who received 8 therapy sessions and no pill. C, if the therapists were allowed to choose who received a placebo and who received D-cycloserine, they might assign people with the more severe cases to the group that received medication, and the people with less severe would go to the placebo. So we wouldn't know if the improvement was because of the therapy sessions and the cycloserine, or if it was because of the severity of their initial acrophobia. So the important thing there is we won't know if it's because they put all of the severe acrophobia people in one group and then the less severe in the other group. So there's confounding happening here. or we're talking about a jasmine scented situation. For me, I think I would use a matched pairs design, but I'm going to show you each. There's a paired design. So each person would do each treatment and randomize the order. A matched pairs design would pair the subjects by their blood pressure, starting blood pressure. And then you group them. One of them does the jasmine scented and the other one doesn't. Is that what? Oh, no, it's the listening to music. So I'm going to order them by blood pressure, and then I'm going to pair them with like the lowest blood pressure, the next lowest, the next lowest, the next lowest. And then within each pair, I will assign one to the listening to music and the other one to the not listening. And then down here at the bottom, notice you have to put in, when the data have been collected, the difference, and I'm listing the difference in the change in blood pressure will be computed for each pair. For the paired design, notice when the data have been collected, the change in blood pressure will be computed for each subject. And then if you decided completely randomized, when the data have been collected, the change in blood pressure will be computed for each subject. So I'll pull that down in case you did a completely randomized. On all three of these methods, there's nothing you can leave out. Like, everything that I have here is everything that you need, and if you don't have one of these elements, you should just assume that you're going to get a P. B, when you describe your type 1 and type 2 errors, you need to make sure that you are describing them in context. So you want to avoid saying the alternative is true, but we conclude the null. You need to use the context for that. So a type 1 error is when the null is true, but we conclude that it's the alternative. Well, instead of saying that, I'm saying concluding, we conclude that soothing music does reduce the blood pressure, when in fact it does not. The consequence is that the clinic will offer music therapy when it's not effective. Type 2, instead of saying the alternative is true, but we conclude the null, we say soothing music does reduce the blood pressure compared to sitting quietly, but we fail to detect this. The consequence of this type of error is that the clinic will choose not to offer music therapy when it would have been effective. When you decide which error is more serious, you really should be mentioning both of them. So a type 1 error is more serious because it will cost the clinic money with no benefit. So that's one way. Sorry, you don't need to include both. I don't know what I was thinking. So one way that the type 1 error could be more serious is that it costs the clinic money with no benefit. A type 2 error could be more serious because the clinic will miss an opportunity to improve the health and well-being of its patients. So it's just showing you how you could have said type 1 or type 2 as long as you justified your answer. You do not need to have both. You just need to have one or the other. Okay, assigning subjects to their treatment group. I always use 2-hat method, so you can see that. And once again, you have to have every single thing I have or assume you're going to get a P. Notice at the end, once again, I have when the data have been collected, compare the cholesterol levels. Why is it important to include a control group? Well, without a control group, we don't have a comparison group. So our people that only drank coffee that was made with the standard filter, that's our control group, I believe. So without a comparison group, the cholesterol level could change overall, but we would not know or would not be able to determine whether the observed change was due to some confounding variable. For example, diet might change with time of the year, and the diet might result in changes to cholesterol changes. We wouldn't know if the change in cholesterol was due to the coffee filter or the confounding variable of diet. The control group eliminates the confounding variable of another change that may have occurred over the 10-week period. So the things that I think are very important in this response is this first part and this last part. The middle part is just giving you an example, and I don't think that that's necessary to getting an E. So you want to say without a comparison group, there could be some kind of confounding. The control group eliminates the confounding variable of another change that may have occurred over the 10-week period. C, we skipped. D, why would researchers choose only non-smokers? Well, if it's known that smoking is related to changes in cholesterol level, it would be best to control for smoking by using only non-smokers. This eliminates smoking as a source of variability, creating a more homogeneous group, enabling more direct comparisons between the treatment and the control group, and more precise estimate of the treatment effects. So that's such a mouthful that what you need to have is that smoking probably has an effect on cholesterol level. So to block for that, we should only use non-smokers, or to block that effect, we should use non-smokers only. It's great if you know that it adds a source of variability. Like, what they mean by that is adds a source of variability means smoking affects cholesterol. The difference in cholesterol could have been caused by the smoking. The difference in cholesterol is the variability that the smoking is adding in. Okay, C, list the treatments. So you could have either drawn like a table like I told you guys to, or just list them out. There's no other way around this. Like, you can't just say 6 treatment groups. You can't just say levels A, B, C, and salinity levels low, high. It has to explicitly be the 2 groups, or sorry, the 2 factors and what groups they make. How will I assign? As usual, I only use 2-hat method. Notice once again at the very end, I have after 3 weeks, the weight gain is computed for each tank and the treatments are compared. What is a statistical advantage to only using tiger shrimp? Well, there's no confounding. There's no confounding due to the type of shrimp. By eliminating variation due to the different types, we are better able to determine if the treatment is really causing the change. One statistical disadvantage is that using only tiger shrimp means that we can only make inference about tiger shrimp. We know nothing about other shrimp. I would recommend that you're actually reading my responses. I'm just not reading them to you because 1, you guys can read, and 2, I'm trying not to waste your time. And then lastly, is this an experiment or an observational study? The only thing you're looking at is, was there random assignment? So yes, there is, so this is an experiment. The hot water group is to investigate whether drinking tea is more effective than simply drinking hot water. And C, we can only make inference about these participants because they were not randomly selected from the population. In order to make inference beyond the 24 participants, they needed to be randomly selected. Okay, that's it. If you need clarification on any of these, please take advantage of me as a resource. Get the help that you need, especially I would try to do it at least before the or by the Friday before your exam. So any questions you have on any reviews, any course reviews, Unit 8, Unit 9, Take Home 7 test, any questions, I would try to get them all answered by Friday the 21st. So don't wait. If you need guidance or clarification on any of the free response or any of the multiple choice, get that help as soon as possible. Okay, love you guys.